It's all about nuts and flanges this week. Need some more nuts. Get some nuts. Just polishing my flange like you do. It's very much like making love to a beautiful woman. Like and subscribe. Door, then you put up your pole and gotta love a good bush.
A la bush. La bush.
The metallastic type that we're talking about, are we?
Yeah, of course.
Oh, okay, yeah, obviously. Yep. Welcome back to Clean Classics. For those of you who don't know me, I'm Ollie. This is our workshop here. This time we will be looking at, we're going to go for a little run, a test run in the Series 3 here, where we've updated some of the sort of control systems and we're just testing through and setting that up. We are also prepping for the LRO show. This Series 3 here, we're going to be putting all of its battery boxes in. They're not actually going to have batteries in it this time, but we want a second car just to display everything nicely. So, so Johnny's going to be going through putting all that together, and 𝗦cie is just doing the finishing touches in the CAD. So we've got a couple of bits to look at there. Johnny has been working on the metalwork, getting this ready. So that's over in this corner, getting prepped, and over the next day or so, we're going to be getting that bolted in. As you can see, all of our stuff's back from the powder coaters, the stuff that you saw Rob welding up last time. So we've got all of the mounts, transfer box mounts, rail kits, cross members, motor mounts, and I'm going to talk you through how we put together our motor mounting plates now. The Leaf motor is capable of 10,000 RPM, so everything has to be aligned bang on. So we drill and ream 2 dowel holes into our motor plate to ensure that the bearing and the output flange go on concentric to the motor. So we've got an old back plate off a motor. We've turned up a little boss that goes into the seal face in the back of the motor housing. That then takes one of our bearings onto it, and then our motor plate then assembles onto that, bolts onto the jig, and we center dot the 2 dowel locations. Yeah, I don't know if you can get a shot of it, Raf, but we've actually, so where the dowel holes are, we've actually machined out 2 dowels in the lathe to ensure that the hole's concentric with the center of the dowel holes. So, and then we've got a tolerance pin that fits in that as a center punch to ensure that those dowel holes end up in exactly the right place on here to ensure that bearing is concentric with the motor. So I've assembled our alignment boss and an old bearing, just a bearing that we've used before for mock stuff that we wouldn't then fit to a vehicle. Yeah, just assembling the motor plate onto the back of the motor. We'll center punch those 2 dowel holes, and then we'll take this back off the jig and we'll drill and ream out the holes in the motor plate, and we'll show you through the process. Hit to make a center punch in the right place for our dowel holes. Yeah, simple as that. Just done is actually drill and ream the holes that are going to align our motor backplate and bearing housing to the motor, and it's a fairly simple process we got there. You saw Johnny with the jig positioning the holes with our tooling. So the next step is get it in the mill, which gives us a really nice, stable, strong and critically flat and perpendicular means of drilling a hole. It being a mill isn't actually, we're not using it as a mill, we're not actually doing the positioning, we're letting the imprint of the center punch guide the tools, but the mill is actually here to give us the sort of stability.
basically the steps we went through were, once we've got our piece set on the bed of the mill, then the first thing you always do if you're drilling an accurate hole is to use a centre drill bit. And this will really accurately follow the imprint left by the centre punch. We take that in until it's sort of half, 3/4 up the chamfer there, and that gives us a nice lead in for the drill bits. We then take a smaller drill bit just to take some of the central material out from where we want our hole. It's always a good idea to stage your drilling so that you don't overwhelm the final cut bit, and that can lead to it wandering off or going a non-round hole. Then we go to about a 1/2 mil undersize from our reamer. Reamers don't like doing a lot of cutting, but they're very accurate to what they cut. So we're doing a 10 mil hole here, a dead on 10 mil. If you were to use a 10 mil drill bit, they commonly cut slightly over 10 mil because of the way that the drill bits can move around, and generally they're not overly accurate way of cutting. So we always go a slightly undersized. About 1/2 mil is a good option. And then we follow it up with the final reaming cut, which is a reamer is another way of cutting a hole, but rather than having the spiral flutes, and actually on a drill bit you cut with the very corner predominantly. A reamer, you've actually got a really accurately ground cutting face all the way up the reaming tool, and that's what allows you to get a really accurate cut. And they just come in the different sizes. So this is a 10 mil reamer bit, and works perfectly for our 10 mil dowels. And then once you've got that, then when it goes on, you know you're exactly in the right place. So, and that's our way of accurately but manually aligning the motor backplate onto the motor, so that our motor output flange and bearing are dead concentric.
Right, so now that we've machined out our dowel holes accurately in our motor mounting plate, we're now ready to assemble the motor output flange with a bearing and a seal in our housing. So it's a shielded bearing which is rated for the right RPM and the right use case for what we're doing here. There's a seal and a couple of circlips. So we're going to go over to the press and put this all together. So when you're putting in bearings, I quite often use, if you haven't got an appropriate sized driver for the bearing, use an old bearing of the correct type. Get the outer race and just slip through it with the slip disc so that it shrinks a bit, so you can get it back out again afterwards, and use that to drive the new bearing in. As you can see, that's our motor backplate fully assembled with the output flange, the seal, bearing and the circlips that retain it all mounted. Dowel holes are drilled, so it's all ready to bolt up to the motor, and then the motor can go in the vehicle.
Last time we were looking at the update we're doing on this Series 3, whereby we've actually changed the ECU and the way we're driving the old Nissan Leaf components. So that is now in. We've gone through all that sort of the procedure we were describing. We've got it running, we've got the throttle calibrated correctly. So now it's running on a base level. We've actually got it tuned right down whilst we're testing it, just for safety purposes. And we've got things like just as we turn the system on, it's doing very much similar thing to what it was doing now. But there's a load of other things that we need to start testing. There's regen, the way it drives, start dialing it in so it sort of suits our preference and how we had the previous setup. So it should end up feeling nearly exactly the same as how it was, but it's just managed in a different way. We're also waiting on an update, a software update that will help integrate this new system with the system we already have running on the car. So at the moment we don't have our fuel gauge running, our temperature gauge running. That's all wired in still, but our box doesn't quite understand the language of the new box just yet. So we're waiting on some of basically that needs to be output from the new box, which we're waiting on that to be released. In fact, a load of stuff just came through, so I'd be interested to go through that. So I think that'll be up and running soon, and that's going to give us we can then run data logging as we test, and we can get a real bigger picture of what the car's up to. But initially there's a few sort of base parameter things we can have a look at by driving the car and feeling, like the regen and other such settings. So we'll take it for a spin and see how she feels. Sketchy test mode. So yeah, right now there's absolutely no feel on the regen, even though we have got a setting in there. So I think we're going to have to feed back to the guys. We have already tried a few different regen settings. I think there might be a little software quirk there, which is, yeah, our suppliers can help us get that sorted. But otherwise, it's a nice, smooth driving experience. Even without a floor down here, we've got prop shafts about to rip Raf's foot off. Yeah, be careful.
Oh, yeah.
Right, so this is our motor output and bearing housing that we worked on earlier, and we put the dowel holes in. I've now put the metal elastic bushes in for where the motor plate mounts to the subframe, and now we're just going to fit it to the leaf motor. So I've already fitted the 2 dowels into the motor casing, so they're all ready to go. Got the bolts, got some new nylocks to lock everything up, and the blind bolts are having a bit of thread lock, and yeah, we're just going to get the motor plate built onto the motor, ready to go in the car. So over the next day or so, we're going to try and get all of those parts you saw on the bench earlier into this car, ready to exhibit at LRO.
So this is the CAD of our Series 1 designs. We take everything that we make goes into CAD software, and then we make part drawings from that CAD software and then send them off to a supplier to be made out of sheet metal. And then once we get that back, we have it all powder coated and put in the car. So my job is designing and drawing up all of the parts and then putting them into a part assembly. So we can see that they all fit, we can test fit them all, and then we can kind of adjust and measure them to fit into the car. This is a part drawing of our rear cross member, which is where the transfer box and the chassis rails and everything kind of mounts into the car. So we make these of all of the parts and then send them to the suppliers, which they use to produce all of the parts out of sheet metal. These are all laser cut by the supplier. From the drawings, we send them with a sort of electronic machine which then folds them all accurately as well, and then they get welded up and powder coated before they put in the car.
This is the left-hand drive car that we've been building. We've put it together as a mock build for the LRO show so that you can see how our system fits in a vehicle. We've got the front battery box in and the main top box that houses all of our electrical gubbins. There's also a motor and inverter in place in the vehicle, and all the battery boxes and transfer box inside the vehicle are all in, and the handbrake set up so that we can figure out that the handbrake linkages and stuff all fit, and yeah, we can overcome the challenges that a left-hand drive car presents. And how we use the existing mounting points of the chassis to mount our subframe into, and then we mount all of our other components onto that subframe. So, and you can see the motor backplate and bearing housing and output flange that we built up a day or so ago is all now mounted to the back of the motor and bolted into the car. Thanks for joining us again at Clean Classics. Hope you've enjoyed it. Like and subscribe.